Welcome everybody, I'm Valentina Lombardo, Marketing Specialist of Vega Italy.
Hello to everyone, I am Mario Ruggeri, OEM Sales Specialist of Vega Italy. Today we will talk about the technology measurement for an efficient tomato processing. We will see the different stages of the tomato plant, and we will analyze some applications where level and pressure measurement are requested. So Valentina, we can start?
Yeah.
Okay, let's go.
We can start, and we start with this slide in which there are pictures of me and Mario's children, and we decide to put this kind of pictures to connect with the Italian tradition that see the tomatoes processing at the center of family tradition, especially in the south of Italy. The steps today are industrialized, but were the same that were made in the garden or in the street, that were equipped with the ovens and bins for cooking. The tomatoes process is and also was a tradition that unites the whole family, from the youngest to the oldest. Do you remember, Mario?
Yes, I remember. Also, the children participate to the tomato processing. I remember when I was a child, I was not a really good child. My job was to stay calm, no damage everywhere, and sometimes I stayed with my grandma to fill some bottles or jars. Yeah, good days. I think it was and still is a celebration, a ritual for all family, with relatives or just with some neighbors, and many bottles for the winter and also just for the Christmas time.
Now let's take a look for global market of tomatoes that see an increase of 2% in the last campaign, thanks to the contribute of China, Italy, Turkey and California. Looking to the Italian market of tomato, also the last campaign closed with an increase of 8%, and Italian is one of the main producers. When we speak about tomatoes products, we speak about different kind of products. The main important we have here on the table, because we have sauce, peeled tomatoes and also concentrate of tomatoes. Also packagings are different, and we have bottle, bins or tubes. As characteristics of tomatoes processing in plants, we have the seasonality. That's because the tomatoes processing lasts in the summer, just few months in a year, with hard cycles of 24/7 in the plants. Also, we have tomatoes that are perishable products that must be processed fresh, and in the plants we work with harsh conditions like temperature, steam or build up.
So let's take a look this animation. Here we can see the typical tomato plant. So Valentina, many traffic today, perhaps. Here we can see the different stages of the tomato plant. The first part is the receiving hopper, where we can see our first tomato, our first sensor for a level application, for example. Then we have the washing tunnel, where we wash the tomatoes, and after that we have the sorting phase, where we remove the spoiled tomato and the still green tomato. After that we have an enzymatic deactivation, where the temperature reach more or less 85 or 100 degrees, and after that the tomato is processed in accordance to the final product. Can be peeled, can be stripped, for example, or crushed or refined. A crucial application for the tomato processing is the evaporator. Here, remove the excess water and regulate the density of the medium, better known as the Brix degree. After the evaporator, we have the pasteurization, then the filling machine. Filling machine, we have many kinds of filling machine. It's a rotative or piston filler, depends on the housing of our tomato. We have the packaging phase and the sterilization. The wastewater treatment are present in the company as well.
In tomatoes processing with fine level measurement. In this part of our presentation, we will show how radar technology can optimize the tomatoes processing. In these pictures that represent an historical scene, we can see a domestic processing in which we find level points. For example, when we have this yellow button, Yeah, here we have a mixing tank and here, for example, a pulper. It's important that the level is accurate and stable, but obviously we find in processing different kind of challenges. The first challenge is to have in the plants different kind of product and different kind of consistencies. That's because we work with solid product like tomatoes themselves or skins. We work with the liquid product like water or sauce, and also with intermediate product when in the same hopper we have, like here, different kind of consistencies. Another challenge is the shot measuring range we find, for example, in the filler machine when the adjustment is made up just in few centimeters. We work with temperature between 60 and 100 degrees, and this means condensate, build-up, and steam. Also, the cleaning procedures are strong for plants because are made with high-pressure water jets, and most of the time also devices and sensors are subjected to this kind of procedures. Now we go to the demo with Mario to show how radar technology works.
So here we are with a typical level application. Here we have an example of hopper, a typical hopper from the tomato plant. Here we have two different level measuring devices. The first one based on the ultrasonic technology connected with a display, and the second one based on the radar technology. Inside we have the display for the big visualization and to set up the instrument. In the bottom of the hopper we have a capacity level switch to detect the minimum level. This hopper can be present before or after the washing tunnel, or after the spoiled machine or the peeled machine, for example. What we can see here, we can show you the challenge what Valentina already said before, so the different kind of medium and the other characteristic of the level application. So we can switch on our machine. As you can see, many tomatoes are coming inside of the hopper. I can put some other tomato inside. And as we can see, the measure of both instruments still works good. And as we can see, inside of our hopper, we have the liquid phase and the solid phase. So we can measure the tomato sauce, we can measure the chopped tomato, for example. Sometimes these hoppers are installed outside of the plant, and the solar radiation are always present, especially because the tomato campaign is in the summertime. Here we can simulate the radiation from the sun on the ultrasonic technology, and if we can see on the display, the measure change immediately, and sometimes the sensor lost the measure. So we can do the same activity on the radar technology, but the radar technology is not affected from the solar radiation. As we already said before, we have the filling phase. Many splash arrive from the hopper. Can be the condensate or, for example, the build-up. I can simulate these two phases. I can simulate the condensate on an ultrasonic technology. The sensor still works good. Same activity on the radar technology, and the sensor still works good. So now we can simulate an harder application for the level device. I can simulate the build-up on the antenna. The hoppers are always small, or every year are smaller, and sometimes the maximum level is too high, really close to the antenna. I can simulate the build-up on the ultrasonic technology, and as we can see on the display, the sensor lost immediately the measure. Same for the radar technology, but in this case, the sensor still works perfectly. So the radar technology is the best solution for all level application existing in the tomato plant. Many kinds of versions are available for the level application. In this case, we already said the Vega Pulse 31, the compact version with a display for the big visualization and parameterization for the 420 milliamps. You can change the application 0 and 100%. For an ultra compact version, we have the Vega Pulse C series. Here we have, for example, with the Vega Pulse C22 with the lateral fixed cable connection with the IP68 protection. Both devices are just with the treat version. If we need an hygienic adapter, we have a clamp version from the teeth to clamp, 2-inch or 3-inch, for example. Both devices can reach 80 degrees and 90 degrees for some minutes, for a few minutes, so it's good for the cleaning procedure. And the maximum range is 15 meters. For the other application, there is the Vega Pulse 64. It can reach 130 degrees and 150 degrees for 1 hour. And, of course, can reach also 200 degrees for the really hard application. Many fitting processes are available here. We have the treat version, we have the clamp, we have the flange, collar connector, or what the customer and the market request.
Now we go back to our plant to speak about pressure. That's because we find pressure measurement in different applications in tomatoes processing. We started to describe one typical application with this animation in which we have a missing tank and at the bottom we have a pressure sensor. Here the challenge could be the abrasion of tomatoes or the way in which agitator there is inside. And the effect of this application we can see in these pictures where the effect and the pressure of the agitators is visible on the vessel and also on the membrane. These pictures represent a metallic cell that is clearly damaged on the membrane. These other pictures represent the ceramic cell that is robust, and the effect of the application and the stress of this application we can see in this part that is the metallic one. Now we will move on a demo to describe and show how a ceramic cell is abrasion resistant. Now we have here a pressure sensor with the ceramic cells. With on the sensor there is just a little bit of water. What I'm going to do is to stress the membrane first with this steel brush, and we will see the effect on the cell. I start. As you can see on the display, the effect of this pressure is visible. When I stop to make pressure on the cell, also the value of the on display back to the beginning. Now I change my tool and I use this screwdriver, and I'm going also to make pressure on the cell, and also on the display is possible to see the effect of this pressure. But when I stop, the sensor can work easily without any effect and no offset correction are needed.
Good. We go back to our animation and we can find another application where the pressure measurement is requested. This application is the pump's control. Here we have the pump, here we have the sensor that can measure the pressure inside of the pipeline. In such situation, the pressure measurement suffer a really high pressure increasing, or a really big peak when the pumps start. Here we have an example of the installation. We have the Vega Bar 80 series close to the curve. When the medium comes back on the ceramic cell, we have a really big peak on the ceramic cell. Again, we have another application with the compact version, Vega Bar 30 series, too close of the pump, and we have, when the pump starts, we have a very big peak on the ceramic cell. So, as the abrasion, we can do another demonstration for the overload resistance of the ceramic cell. Here we have another demo, our Vega Bar 38 with the ceramic cell, 10 bar of measuring range. We have the manometer to measure the pressure inside of the pipeline, and the hydraulic cylinder to simulate the pressure inside of the pipeline. The Vega Bar 38, in this case, has, with the IO-Link protocol, we have two digital output we can set. The first one, for example, is 2 bar, and the second one is in 4 bar. Now we can simulate. So now the LED is green, no alarm. The sensor works good. We can simulate up to 2 bar. Okay, so we can see the yellow and the red one. 2 bar and 4 bar. So now we can simulate the big peak on the ceramic cell. Sorry, Valentina, the screwdriver is not enough. I bring this hammer and simulate this peak. As we can see on the manometer, we reached more or less 20 bar, are 10 bar higher than the measuring cell. And now we check if the sensor still works good. So the LED is green, no alarm. The sensor works good at the moment. We can check the first alarm and the second alarm up to 4 bar. Good, okay, the sensor still works good. So if 20 bar are not enough, we can do a really big peak with a bigger hammer. I will try to be my best with this bigger hammer. I reset the manometer for the really correct measure. Good. And now I try again. Okay. As we can see now in the manometer, we reach up to 100 bar, so 10 times higher than the measuring range. Check again if the sensor still works perfectly. Again, the LED is green, it's normal, no alarm. We simulate 2 bar for the first alarm. Okay, change the color in yellow, and we simulate up to 4 bar. Good. Change the red color. So the ceramic cell is the best solution for all pressure application in the tomato processing.
Now let's take a look to Vega portfolio for pressure sensor. I have here pressure sensor with compact dimension that let an easy integration in the plants. All these kind of sensors are available with the ceramic cells, and we have seen the characteristic with these 2 demos, but also with metallic cells that is indicated for cleaning application like in pharmaceutical industries or some application in the food industry like, for example, beverage. We have also the LED that we can choose the color between 256 different colors, and also we have the version with display that let an easy readability of the measured value, and this head of the sensor that is rotated 260 degrees and also tilted 45 let an easy read of the measure value from the operator without to go above the measure point. Vega developed this kind of sensor to work in food process, so all the approval for work in food plant are present, but also we have the version for demanding application like, for example, EP68. Also develop a system of hygienic adapters like clamp version or Varivent. For demanding application, we have also Vega Bar Series 8 for example, application with high temperatures or different kind of requirements. Now we also go back to our plants to speak about of one of the most important application and phase in the tomatoes process, that is the evaporator. It's important that here the level measurement is stable and accurate to avoid shutdown of the plant due to an incorrect level. In these pictures we can see the evaporation application, and the level measurement here control the input of tomato sauce in the tubes, and with the forced circulation, that is the reuse of the steam for 5 or 4 cycles, there is a reduction of the energy consumptions, and also the steam led to have a lower temperature, that means to have a right quality of the product, that means to have the tomato with the red color that is typical. The most of the time the evaporator is outside, so it's important that the level measurement is not affected by temperature or, for example, sun. For this kind of application, we recommend to use an electronical differential pressure transmitter for level measurement. In this way, we can use the ceramic cell that we have already seen the characteristic in 2 live demos, but also to avoid the use of capillaries that with the oil inside can be subjected to the high temperatures. Now we will see another demo to describe this kind of application.
So here we have a typical level application where the differential pressure measurement is requested. Inside we have the level, and probably here we have, for example, the overpressure or the vacuum inside. Here we have two kind of differential pressure devices. The first one is the conventional differential pressure with a capillary and the metallic membrane. And the second one, based on an electronic differential pressure, we have 2 different devices. The primary devices measure the level and the pressure or overpressure of the vacuum, and the secondary instrument measure the overpressure or the vacuum inside. The 2 devices are connected with an electrical cable, so no capillary are present here. What we can simulate here is what can happen for the evaporator. Sometimes, or normally, the evaporator is installed outside of the tomato plant. I can simulate the solar irradiation from this phone on the capillary. As we can see on the display, the measure change immediately, even if inside the level still is the same. I can do the same activity on the electronic differential pressure, but of course here we have just an electrical cable for the connection between the devices, and of course this in this solution is not affected from the solar radiation. Of course, the electronic differential pressure allows us to use all advantages of the ceramic cell.
We go back again to our tomatoes plants to speak about the level switches measurement. That's because we find this kind of measurement in different phases, for example in the pulper or in the correction phase or in the peeling phase at the end of the process. We have here with animation to show how peeling phase works, and the tomatoes go to the top roller and are transported to the heating unit, where stays for 12 or 50 seconds. After, go to the unit with vacuum unit, in which when tomatoes hit the vacuum, lost naturally skins. And skins go to this hopper, where we find the Vega point capacitive level switches for minimum and maximum level. Here there are some pictures from the plant in which we can see our Vega point level switches on as minimum or maximum level. And what we can note that is this sensor works with different kind of consistency of the product. We have solid or liquid product. And also, like in these pictures, Vega point works with build-up. To work with these conditions, it's important to make a little adjustment, and now we see this little adjustment in our last demo with Mario.
Yes, here we are with our last demonstration of this presentation. Here we have the Vega Point 21, the capacity level switch, connected by Bluetooth to the Vega Tools app. You can download this app, it's free. You can download by Apple Store, or Google Play, or depends on your smartphone or tablet. So now I will simulate, for example, the maximum level on the hopper or inside of the tank, for example. So now we have the LED is green. I can simulate the maximum level. So change the color of the LED in red. So go out our device, and we can see the LED is still red. So we have the false maximum level at the moment. So what we can see, what we can do, we can regulate the capacity of the device. We can regulate the covered and uncovered situation of the sensor. So I choose when the sensor we have the really large build-up. I can select the uncovered output. So simulate again the real maximum level. Apply the adjustment values. And as you can see, now the sensor works perfectly.
Now let's take a look of our Vega portfolio for level switches. We have this sensor that is a Vega Swing vibrating level switch, completely in stainless steel and adjustment free. Then we have Vega Point that are capacitive level sensors, and with the compact dimension. This is the entry level with an easy compact dimension for the integration in the plants. We have the LED that is characteristics, and also here we can choose the colors. We have the version with this tube that can be longer 1 meter, and we have this sensor that is Vega Point 24, completely front flash, so recommended for application with sticky products, and in this way we can have no shadow zones. Also for these sensors, Vega designed a system of hygienical adapters for the integration and flexibility in the plants. We have finished our presentation.
We can reach the end of the presentation.
Thanks to stay with us, and bye.
Thank you. Ciao.